y squared, w squared y cubed minus 8w y squared. So what we need to do is to look for factors that go into both of these two terms. The first thing obviously is 8. So if we take out the 8 threes are 24, so we get this minus wy squared. Okay, now anything else? Well, we've got y's and w's in both of these, and if you look, we've got a y squared and a y cubed. Well, y squared goes into both of those, and we've got a w and a w squared, so w and y squared can both come out, and that leaves us with 3wy, because we need another w to times by that w to give us the y squared. We need another y to times by the y squared to give us y cubed, minus the w's there, so we don't need any more w's, and the y squared's there as well, so we don't need any y squared, so 1 will do it. And that's done. That's the first one. Right, now B is a bit of a weird one. It's a little bit harder because, in a way, because at first you might look at it and think, well, we can't factorise it because there's nothing that goes into each of these terms. You know, there's E here and here, but there's no E's here. There's an F here and in the first term, but there's no other F's. There's no number that goes into 2 and 3. However, it's 4 separate terms. The term on the end is just a number. So if you remember, when we multiply out brackets, which we do, for example, with quadratics, when we multiply out brackets, we expect to end up with 4 terms. The term at the end will be a number. So, and that's going to have to be a 2 and a 1. Remember that we need to multiply it out like this. So whatever that first term is, times the first term there and the second term, and here the 2's got to go to whatever that is, and then times by 1. So if we remember that that's what's going to happen, we can look for terms to go at the front here and here, which are going to give us the correct answer. Well, we want 3EF. So if we just try 3E and then put an F there, let's see what happens. The first term, 3E times F, is what we want, and then we want a minus 3E. Well, 1 times 3E is going to be 3E, so if we make that a minus, we've got the first term. Now we've also got the second term. Now, to get minus 2 on the end, we've got to multiply minus 1 by plus 2, so if we put a plus there, and you can then see that when we come to multiply out along these lines here, we've got a plus 2 times an F, which gives us our 2F, and a 2 times minus 1, which gives us our minus 2. So we've done it, and that's the answer. Now part C, 225 minus 4x squared. Expressions like this have a special name, and we call them the difference of 2 squares, because 25 is a square number, 5 squared is 25, but 4x squared is also a square number, because if we square 2x, remember that 2x squared is the same as 2 squared times x squared. Whoops. Right. Click. Is the same as 2 squared times x squared. which is 4x squared. So this is indeed the difference of two squares, and there's a very simple way we do this. It's going to be 5 and 5, 2x and 2x. Now when we multiply it out, we don't want any x terms in the middle here, which means we've got to give one of them a plus and one of them a minus. And then that works, because you can see if you multiply these brackets out, you get 5 times 5, which is 25. Then we get minus 10x plus 10x. So the 10x is cancelled out in the middle, and we end up with 2x times 2x, which is 4x squared, and it's a minus. So we've done that one.